Hey everybody, this is Jules from the dev team. Today I'm going to show you the Dusk Transfer Contract. So I guess I'll start a bit with the background info. The way this is set up, so we have the very well-known Golang Dusk node running in the background. Besides this, we have the RUSK server, which is containing the virtual machine and the contract storage. So these are connected through a gRPC connection. So the Golang node has a client that makes a request to the RUSK server, which has a gRPC server. And with these requests, we can then call into the virtual machine and do contract executions. So it's basically a way for nodes in the network to transfer their Dusk coins through the use of a smart contract rather than having a UTXO model that is outside of the contract layer. And the reason we do this is to basically unify the two different states that we otherwise would have between the UTXO model and the smart contract model, which would have all of the tokens and the STOs and stuff going on there. So if we have two separate databases that we need to manage, we sort of open up a lot of possibility for, let's say, race conditions, and this makes it really easy for nodes in the network to desync with one another. And if these nodes desync, it means that the network will stall, and then our blockchain will basically just run to a halt, which we don't want. So the beauty of this is that we can unify the state and avoid all the problems that we would have if we had two separate databases, but we still have the full confidential UTXO model implemented inside of a smart contract. So that way, both of the transaction models are essentially reconciled and unified. Since we are doing Dusk transfers through the smart contract, it needs to be the very first contract that is being uploaded on the blockchain. Otherwise, there's no way for us to actually use the currency. There's a couple more. There's going to be a fee contract, which is going to take care of distributing rewards to the provisioners and block generators. And besides this, we've also chosen to manage the provisioner committee and the set of blind bids through two separate contracts as well. The virtual machine essentially has no idea of what is going on inside of it, which definitely helps with the confidentiality. All right, so I guess I'll show off the demo now. So I'll show on the code right quick here. I've commented out this line, which deploys the transfer contract, and the contract ID here is set to default. So I'll now try to make a call to the smart contract, and it's most likely going to fail because it's referring to a contract that doesn't exist. So let me try this. Node is starting up. I'll check the server. And here we see an error, unknown contract. So let me take this down. I'll do a quick check on the Phoenix database to see if there was any money that was transferred. And we can see that the receiving address still has a balance of 0. So now I'm going to add this contract ID to the server so that we can actually refer to the right contract. Restart it up. All right, so it's back up. So let me try again now to call the contract. Go over to the RUSK server. It should show us when it's calling the contract right here. And now it should be done. So let me check the Phoenix database again. I'll check the receiving address. And now you can see we have 97 Dusk on this address. So now we have facilitated a Dusk transfer fully through a smart contract. That's basically it. So a little bit about the gas cost of the execution. So much like Ethereum, we use a gas model to basically decide how much of the fee is going to be used to pay to the consensus nodes. So for this execution, the gas was calculated as it happens inside of the virtual machine, but we don't have the fee contract deployed. So what the fee contract does, it receives the spent up gas, and from the transaction fee then distributes that fee to the block generators and the provisioners that were running the execution basically. So much like in Ethereum, the gas is basically sort of a unit that determines how much you pay for your computation. And then the fee of the transaction is the money that you use to cover the gas.